Hey makers, in this video I have a very cool project. We'll learn to design and build this. It's a 3D printed mini pottery wheel that actually works. Check it out. And believe it or not, you can make all of this for just a few bucks, which is pretty cool. Note that I prepared this tutorial for all levels, so whether you're CAD advanced or just a beginner learning the basics, you'll have no trouble following along. Let's get started. Okay, let's run through what you need. You will need access to a 3D printer. We're going to do just a little bit of soldering as well. You'll need a screwdriver, and I do recommend a caliper. It'll be pretty useful in taking measurements. Now, the more specialty items, you will need a geared DC motor. These are pretty common. You find them in little robot cars all the time. And you also need a USB cable with a switch, and the other end should be stripped. Make sure you've got 2 screws. I'm using wood screws that are 3mm by 30. And at last, you want to pick up 4 bearings. I recommend that the inner diameter is somewhere between 5 to 10mm. And of course, you'll find links to everything in the description. By the way, totally cool if you don't want to do the CAD part. You can find my model in the description. Maybe you just want to build this, but please help me out. Watch the video through, like, subscribe, anything that's going to help my channel grow. I'd hugely appreciate it. Thank you. Okay, let's get started. Here's a quick preview of what we're going to design. Okay, I'm using Onshape. It's a really great app. Go ahead and click on Create, and we'll make a new document, give it a nice name, and click Create. First thing you want to do is select the front and create a new sketch. Push in on the keyboard or click the front here, and now we've got that nice 2D view. Start by selecting the line tool, which will snap to the origin, and the motor measures about 65 across, so make sure this line is much longer. Let's put 80mm, and then a vertical line of 40. Next, select offset, and we'll offset these lines, pull them in, and we'll change this dimension to 5. Tidy that up a little bit. All right, I'm going to use the spline tool now, and what I'm creating here represents the outer wall. You can decide whatever that shape is, customize it, have fun with it, but I'm just going with the basic smooth curve using the spline tool. All right, use the line tool to close here and close this end. It should turn gray inside the lines. Now select the revolve tool. Make sure that you're on solid. Select all of these faces inside the lines, and then click here on revolve axis in red. This will be our center axis. Click on this line, and there we have it, a nice revolve. Okay, confirm that. Now select this surface of our part, and let's create another sketch. Push in on the keyboard. Okay, go ahead and select your circle tool, and we'll put a circle right here of about 5.4mm. which is pretty close to what I'm measuring here on the shaft of the motor. Okay, next select a center point rectangle. I already measured lengthwise. Width is about 22.5. Length was about 65.5. And here we go, let's put 22.6. Let's move these over here and here. Okay, select the point tool and let's add a couple of points. Make sure everything snaps, follow those yellow dotted lines. And then we'll add some dimensions. So from the point to the outside in this direction and this direction, I'm measuring 14. Let's go ahead and click here and here. That's 14. And here and up here, and that distance is 14 as well. Enter. Okay, now let's make a vertical line. And the distance between will be 37. This will make a little more sense later. Now a very small circle for the hole. This is pretty close to 3mm, so let's dimension that, drag it down, and we'll add some points here and here for dimensioning. Now from this point to the outside, I'm measuring about 1mm, and from here to here, I had about 29.5. Tidy this up a bit. Okay, so let's mirror the circle to the other side. We'll click this plane as the mirror line, and then the entity is the circle. Let's click it, and there we have it, 2 circles. Okay, let's close this gap, add a line from this point to the curve and also from this point to the curve. And now let's offset all of these lines and drag them outward. This is going to be a wall that holds the motor. Set that dimension to 5mm. And at last, get that center point rectangle again, and we'll put a rectangle right here, center aligned. Dimensions are 5 by 5. Okay, save the sketch. Now we can start to extrude. Select absolutely everything that is inside of the sketch right here, and then extrude. And we're going to point that down, adding material all the way up to this face. Click right here on the floor of this, and it stops at that point. Confirm. Okay, make sure that sketch 2 is visible, click on this eye, and then select these parts of the sketch. Okay, another extrude, change to remove, up to face once again, click on the floor here again, and confirm. Okay, now click here, and another extrude. Let's remove once again. This will be the depth of the motor, pretty close to 20. Let's remove that much here, and confirm. All right, select this little square, and another extrude. We'll remove, take out about 15, and confirm. Next, select the wall here, and we'll place a new sketch. Choose a center point circle, and make sure that it's aligned at the center of the line below. Click and add the dimension of 3.3. And we'll make the distance from the line to the circle here 10. Okay, select the inside of the circle, extrude, remove, and we'll remove through all. That will go all the way out the other side, and that's for the cable. This is where the caliper is important. Make sure you measure your cable and that it fits perfectly. Okay, now select the surface, extrude. Make sure you select up to face, and we'll remove up to this wall. Click here. Okay, confirm. Now select this surface and let's do a new sketch. We'll use the circle tool to create a small circle here. Set that to 3 millimeters, and any approximate distance is fine. Let's do 5. And now select that whole extrude and let's remove up to next, which is the other side. And that's just in case any water gets inside. Don't think it's going to happen, but at least there's a place for it to escape. And confirm. Okay, for this next technique, we're going to do a thicken and remove just a little bit. I'm going to take off 0.2 millimeters, and we'll shave off a little bit of these surfaces where the motor inserts so that we don't have too tight of a fit. It'll be just perfect. So select all of these and confirm. We'll do thicken again here as well, but let's take off a little extra. I think 1 or 2 millimeters is fine. And that's because there's a shaft that points out the other side. Okay, confirm this. And let's do another thicken, but let's not remove, let's add material. I want to add 0.5 to this hole and this hole. And this is to make sure that it's tight so that when the screws are inserted, they really grip the plastic. All right, this is mostly for looks. I'm going to put a chamfer here of 15 millimeters on this line. And I just feel like it needs a little tiny baby fillet. So let's put one right here on this line and confirm. All right, next let's make this for the bearing. What you want to do is create a new plane and make sure you're on offset. Now the entity is this plane here, which is the right plane, and make sure you drag it over to this side. Now the distance between planes, you'll have to experiment. I'm going to go with 75 or maybe 74.5 is better. Yeah, that's perfect. The plane, you can see the edges are touching here and over here. So I'm going to sketch right here just inside the walls. Confirm that plane. Now select plane 1 and create a new sketch. Select the circle tool and make sure you're snapping on this line. Watch the yellow dots. My bearing has an inner diameter of 6 millimeters, so let's make it 5.9. I want that to be a really tight fit. And I'll make an outer circle. This represents the outside of the bearing, which is 15. And then I'll put a point right up here. And from this point to the line here, let's set that distance to 2.5. And the top plate's going to be stabilized by the bearing. It'll make contact here and stop at that point. Okay, confirm that sketch. Select the inner circle and let's extrude. Click on second in position because we'll extrude in 2 directions. This direction will be about 6 millimeters. And the other one, I think 2 is fine. Very important, change this to new and then confirm the sketch. All right, so let's go to the front plane and create a sketch on the front. We'll make a line. It can be a construction line by clicking here. And just make a very small one vertically like this, push escape, and save. Okay, now click up here. We're looking for circular pattern. We're going to make duplicates of that little peg. All right, go ahead and select your part 2 right here. And then click on the axis in red, and we'll select that line we made on the front plane. Instance count should be 4, and change this to add. And merge with all. Now we have one single part, and we can confirm. All right, I'm putting fillets everywhere. I'm not going to bore you with explanations of this. You can put them as you like and the sizes you want. Overall, this is mostly just for aesthetics and also some structural strength on the 3D print. You can go as far as you want. I've sped up this video to get us through it. And now on to the next step. Okay, select this wall here and let's create a new sketch. I'm going to go through this a little bit quickly as well and not explain it as much because it's really optional. The goal here is to add some ventilation, just in case the motor gets warm or hot if it stalls too much. I've tested this and I haven't had any serious issues, but I thought, it might help just to allow a little bit of extra airflow to the motor. And to be honest, it kind of looks cool, which you're going to see here in a moment. Speeding this video up quite a bit, but you can always slow down and pause if you want to follow these steps yourself. Okay, at this stage, I've got a line, I've done a linear pattern, slotting, and I'm going to go ahead and extrude that now all the way out to this face here on the other side. I think that looks pretty cool, and it'll definitely allow for some extra airflow. Okay, final step on the bottom of this, let's add a little slot where that drain hole is. I realized if there is any water and it needs to drain out, it's going to have a really hard time being flat on a tabletop. So we need some kind of channel where it can drip and leak out. Also speeding through this because I really am not sure that it's necessary. This isn't built in a way that water should get inside. It's more of just an extra precaution. So you can slow down the video and watch the steps if this is something you want to do. All right, the hardest part is over. Let's go ahead and make the top piece. Select the surface right here and let's create a new plane. And we'll offset that 2.5 millimeters. Let's confirm. Now on that new plane, create a sketch and push N on the keyboard. We'll make a circle right here at the center, and it should be about 165, I think is good, sitting just beyond the wall of part 1. Okay, click offset, and now click that circle you made. And let's offset a few millimeters. I'm choosing 3. Next, another circle at the origin. I'll make this 5.45, and let's create a little rectangle here, and this will be 4.05. This will be the shaft hole. Let's confirm. Now select everything inside that sketch and extrude. Make sure it's pointing this way, and I think a depth of 7 millimeters will be perfect. After you confirm, start another extrude and set to remove. Select these sketch faces, and remove about 6 millimeters. Confirm and select this face at the bottom of part 2. Let's extrude that. Make sure it's pointing down, and I think 5 millimeters is good. This will cover here a bit, but it won't touch the walls. Okay, let's add a fillet on the inside. That'll give it some strength, and we'll put some small fillets here. And a chamfer here, 1 millimeter looks pretty nice. All right, that's it. Let's send this to print. Already looking good.
While that's printing, let's take a moment to high-five ourselves for making something cool. Design projects like these are always fun because they really challenge your brain, and that's why I love today's video sponsor, Brilliant. Brilliant is this awesome learning app packed with hands-on lessons and things like math, science, data, programming, and even AI. But it's not boring textbook stuff. It's actually fun. You interact with the concepts, solve real problems, and have the opportunity to play as you learn. And because it's all hands-on and available on your phone, even in just a few minutes, you'll learn something new. So if you too find yourself layer watching for long moments on end, let's replace it with brain training. You can try everything Brilliant has to offer for free for 30 days at brilliant.org/makerverse, and you'll also get 20% off an annual premium subscription. Use the QR code or find the link in the description. All right, let's check our prints and put everything together.
Main body looks good. Seems like a slight layer shift here. That's a little weird, but not bad. I did forget support on this, but it actually seemed to have survived. And now the top piece, that texture is good. It's going to grip the clay. And I tried a red version too. Okay, let's build. I've got these 2 pieces ready. I've got 2 screws and my motor. Make sure your screws pass through the motor well. Mine are about 30 in length, and I've got about 10 millimeters to sink into the plastic. And again, these are 3 millimeter in thread diameter. All right, we've got the 4 ball bearings. I'm at 15 on the outside and 6 on the inside. Here's the USB cable. It's got this nice switch here to turn it on and off. And we'll solder this part to the motor. Okay, let's build. First step is to insert the cable. This is a really tight fit, but that's exactly what I wanted. You can solder it this way or this way. It'll just change the rotation of the motor. One way will be clockwise and the other will be counterclockwise. Thread this through and bend it over just a little bit so it doesn't slip off easily. And we'll do this on the other side here too. Do be careful, these break really easily. I've snapped them off the motor before. All right, we'll get this side soldered. And now the other side really quick. That looks pretty good. Carefully pull this cable back until the motor sits nicely. Let's add the screws, 1 and 2. There's a point here for another screw, but this is strong enough. All right, now the ball bearings, and that is a nice perfect fit. Even with that mess from the missing support, these are fitting very nicely. It's optional, but you could add a little bit of hot glue here. That would protect the circuit and also hold the cable in place. All right, let's insert the top here on the motor. That's a good tight fit. Rotation is working perfectly. This looks really good. Okay, let's plug it in and give it a try. Perfect. Now I recommend you add some weight, otherwise this thing might shift on the table. I thought about sand, but I didn't have any, so I just added some of this salt. All right, let's put that back on. That feels good. I think it's time to put this to the test. So my daughter volunteered. She was the first one to try this thing, and we put this big chunk of clay on there. I think we put too much on the first time, and there wasn't enough water. So we switched to this smaller piece, and it's pretty awesome. It actually handles it pretty well. You got to make sure that you're using enough water, but how fun is this, especially for kids, to be able to make mini pottery? And here's my piece. I know it's a little bit sad, but it was the first go, and I'm having fun too. All right, that's the end of this video. Thanks for watching. I hope that you're inspired and you make your own. Please hit me up in the comments. I want to hear how it goes. And of course, if you have any questions, I'm there to help. Hope you have a great day. Bye.